A, B, and that terminates. But that's not an accept state, so reject. Okay? So that string AB is rejected. How about BA? BA. So you terminate in state R2. That is not an accept state. So reject. All right. How about BBBA? BBA. So your final state is R2, not an accept state. So reject. That string is rejected. Okay. So a bit of a description. So we call this automaton, this machine, M4, fourth example. Okay. So obviously now, which is the start state? Well, as usual, you go looking for the detached, the arrow that comes out of nowhere. Well, it's obviously this one. Okay. So this is pointing at the start state, which is S. Right. So it starts in state S here, and then it will branch left or right, depending on the first symbol in the string that it sees. Now, the alphabet of the string is just A or B. So that first symbol is going to be either A or B, right? And depending on which one it is, if it's A, it'll branch left. And if it's B, it'll branch right, to get the next state. Okay? Right, so it reads the first symbol in the string and then branches left or right. Now, if it's an A, it'll branch left into the so-called Q states, because these states on the left here are labelled Q, and if it's a B, the first symbol that it reads, it'll branch right into the so-called R states, because these right-hand states are labelled R, R1, R2, the left one's Q1, Q2, right? And notice also, a remark here, once you've branched left or right, you can't get back to this state. Now that's new, I haven't had that before. Before we could get back to the start state, I think. Well, anyway, here you cannot get back. It's irreversible. This is like a one-way street. There's no path to get you back to S. Right? Alright, so now if the first symbol's A, so it'll branch left, and it will accept if the last symbol is A. Now you're starting to come to some conclusions about the function of this automaton. In other words, the nature of the language that it recognizes, the nature of the strings that it accepts. Okay. So it goes left and accepts if the last symbol is A. Now, does that make sense? So the first symbol is A, so now we're here. Now, if the last is B, it will accept. Hold on. Is A. So if the last symbol is A, okay. So say the next one is A, so it stays here. That'd be accepted. I'll say then say you had like BA, or BBA, BBA. So so you could have as many B's as you like, and it'll just keep looping until it gets a final A, and it'll take you back here. So that seems plausible, right? Now you have a similar story on the right-hand side. So long as your last symbol in the string is a B. So say you had A, B, and then A, B. Okay, so as long as the last one is a B, you'll end up here. So similar story as with the left-hand side. Okay, so you can come to a conclusion. Therefore, the automaton M4. It accepts all the strings that start and end with the same symbol. Okay, so if it's M dot 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 A, sorry, if the string is A dot 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 A, it would be accepted. And if it's B dot 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 B, it starts and ends with the same symbol, it would be accepted. Okay? So that's the function of that automaton, and hence its language. You could write out its language be the set of all W. W is just string, such that, you know, vertical line, that W. So W, like if you have a string of length n, okay, then W1 and Wn are the same, either A or B. Okay, that would be the definition of your language. Alright, now here's another one, a second example of an automaton. It's a bit more complicated, well in some sense. So this is example 1.13 in the text, you know, using the same label as the example. So we'll call this M5, it's like our fifth example. And what this is doing is it's probably closer to your conception of compute. It's actually calculating something. So this is starting to do arithmetic, if you like. It's it's closer to what you probably conceive as a computer as. Right? Now, there's not enough space in this session to tell you what's going on. I'll just throw it at you, and we'll do it, you know, more completely in the next session. But basically, what this thing is doing is that it's looking. Well, for its alphabet is reset. Now, I'll explain in a minute what that means. But the critical thing are that these digits 0, 1, and 2. And this automaton looks at these integers 0, 1, and 2 in the string, the input string, and just adds them up. Right? So it's a kind of adder, but a special kind of adder. So this running sum, in other words, the sum that you are at the moment, depending on where you are in reading the string. So as you move through the input string, your sum, you know, will change. You keep adding terms to it, and that sum is the sum it would be mod 3. So you're modding the sum mod 3. So for example, say the input string is just a whole bunch of ones, just 1, 1, 1, 1, 1. So your running sum would be, you know, start at 0. And then 1, 2, and then it can't be 3 because it's mod 3, so it'll be 0 again. So your running sum would be 0, 1, 2, 0, 1, 2, 0, 1, 2. Okay? Now if it reads a 2, well, it jumps, instead of adding 1, it'll add 2, and then check for the mod. So every time it adds either 0 or 1 or 2, it gets the answer, the sum, and then mods the sum. So if the sum is a multiple of the running sum is a multiple of well, if the total sum, if you added all the, is that true? Yeah. So the total sum, if you added all the numbers, integers, without modding, this automaton would accept if that total sum was a multiple of 3. So that's the language. So the strings in the language for this automaton are all those strings whose sum of the integers in the string are a multiple of 3. Okay, so it's a kind of calculator. It's the beginning. Okay, now so the alphabet consists of 4 symbols. Now assume this thing here, just called reset, is a symbol. It just treated as a single symbol. And what reset does is it takes your count, your running sum, to 0. Okay, so reset, you know, put back to 0 in effect. Okay, now so we've run out of the session. Yeah, I'll just go straight on to the next session.